Hello guys, in this video we will see model evaluation and partitioning. In the previous video where we discussed about overfitting and underfitting, we said that dividing or partitioning the data is one of the solutions to reduce or overcome overfitting. Right? Here we will be seeing some of the partition technique or cross-validation technique. Here we will be seeing what partitioning of data as training, testing and validation, and shortcomings for standard approach, k-fold cross-validation and variations in cross-validation approaches. So, why do we need to partition the data as train, test and split for better performance and to reduce the overfitting? So, to check how well our model perform on fresh data the model has not seen before and how to reduce the scope of overfitting, the partition the available data into minimum 2 parts or ideally 3 parts. This suits for a very good model. As we know, suppose if the available data set, let's consider it's 100%, we can either divide it into two portions, either training data 60%, test partition 40%, or we can divide it into 3 parts, which will be using as train, test and validation. Here will be training partition will be 60%, validation will be 20% and test will be 20%. Now coming to k-fold cross-validation, this is one of the type of cross-validation, which means we will be having an entire data set. See, the problem here, we are actually training the data, train, test, splitting the data. If we have a data set, see, suppose if you are taking the first 60% of the data as training and last 40% of the data for testing, the distribution of the classes in the data might not be equal, right? Suppose we are dividing a data which is classified into S or no. Suppose first 60% is full of S data and last 40% is full of no belonging data. We will train on only S. Now if we give no, how can our model predict? So no, right? Here we have to do the partition in such a way that each training will be having equal proportions of S and no. Testing will be having equal proportions of S and no. So this cross-validation is very important. We shouldn't just divide the data. So here one such cross-validation technique is k-fold cross-validation. This is an alternative to data partitioning, especially when the number of records in the data set is small. Here what we will do, partitioning the data into folds or non-overlapping subsamples. So here we are having the data, right? So here we will be dividing the data into folds. If we choose k is equals to 10 folds, meaning that the data are randomly partitioned into 10 equal parts, where each fold has 10% of the observations. See, this is good, right? So now in the end we will perform the average of k test performance or best of k models. For each k fold in your data set, build a model on k minus 1 folds of data set. That means if we are taking this fold as our data for testing, we will be building the model on this for training. If we are taking this part for testing, on the remaining part we will be taking a training. So here every fold covers the training data, and every part covers for testing data, which is the best approach, right? Record the error you see on each of the predictions. Repeat this until each of the k-fold has served as the test set. So here see, every fold will be serving as test set and every fold will be serving as training set. So there won't be any misclassification of the classes, right? So the average of your k recorded errors is called the cross-validation error and will serve as your model performance metric for the model. Now here, as we chose the value of k in k-min, how can we choose the value of k in k-fold cross-validation? On small data sets, lower value of k could increase bias and hence not desirable. So here also we should not take value of k as small. Higher values of k reduces bias but increases the scope of variance. So higher values of k also not preferred. Special case is what? K is equals to n, referred as leave one out cross-validation. This is also a type of cross-validation, or n-fold cross-validation, where n is equals to number of training points. Reserve only one point on the available data set and train the model on the rest of the data. This process iterates for each data point and hence k is equals to n, but this is computationally expensive. Now we will see some of the variants of cross-validation. What is this? Leave one out cross-validation, LOOCV, where we will take k is equals to n. Then we have Startified. What is Startified cross-validation? Each fold has the same proportion of observations with a given categorical value, that is genuine or fraudulent or yes or no. Here initially in k-fold cross-validation we just took a fold. We don't know how many samples of yes or no belonging to that fold, right? But in stratified, even that fold, in that particular fold, there should be equal, such as the class outcome value. Repeated cross-validation. What is repeated cross-validation? K-fold cross-validation procedure is repeated n times. The data sample is shuffled prior to each repetition, which results in difference splits. Then we have nested cross-validation. So K-fold cross-validation performed within each fold of cross-validation. See here we are performing K-fold in each and every fold. Oh my god. Often to perform hyperparameter tuning during model evaluation, also called double cross-validation. Here we are doing cross-validation inside cross-validation, right? Here we can see the diagram representing stratified class cross-validation. Now let us see the summary what we looked into. Here partitioning the available data into training, testing and validation data set, and performance might vary if the split points were different and training and evaluation were on different subsets on the same data set. So instead averaging or multiple iterations of such partitions is better for single train validation partitions of the data. So why do we use k-fold cross-validation? It's used for parameter tuning to arrive at the optimal values of parameters of a model before applying it on the test data. So this is cross-validation techniques and partitioning techniques. Thank you.